Good morning. Today I'm going with the Spark next lecture about Spark datasets. So we are going to cover about what is the Spark datasets and the differences with data frame and datasets, and then what is the use cases of datasets. And then next coming lecture we are going to do some example. So as per the definitions of in Databricks, so dataset is a strongly typed, means is to check the type of data, an immutable collection of objects that are mapped into relational data schema. Datasets are type-set structure API available in statically typed. Spark supported in language Java and Scala. So datasets is only supported in Java and Scala. Datasets are strictly the JVM language features. Datasets are not supported in R or Python since these languages are dynamically typed languages. After Spark 2.0, RDD was replaced by dataset, which is strongly typed like RDD but with richer optimization under the hood. So datasets, if you see here, a language Scala supports DataFrame datasets, Java support datasets, and Python support DataFrames, R support DataFrame. And type is untype, both support type and untype in Scala. Java only support type, and Python generic row and type generic row, and the R is also generic row effort. So in the context of Scala, we can think of data frame as an alias, a collection of generic objects represented as a dataset rows. The row object is an untyped, is a generic JVM object that can hold a different type of field. In the constructs of dataset is a collection of strongly typed JVM objects in a Scala or a class of Java. It's fair to say that each dataset in Scala has an untyped view called DataFrames. So DataFrame is untyped, which is a dataset of row. The following table, as you see, yeah. So what is the difference with the DataFrames? DataFrames and datasets. So we need to construct our data frames and datasets to gain the better understanding. Datasets check if the type conform is specific at compile time. Data frame are not truly untyped, as their type are maintained by Spark, but verifying whether the type conform to the specification in the schema is done runtime. Said another way, data frames can be though the datasets of type row, which Spark internal optimized in memory representation for the computation. Having its own internal representation of type allows Spark to skip JVM type that can be slow the initiates and have a garbage collection cost. We will study the aspects. So this is some kind of benefit, like Spark will do the data checks and somewhere JVM will do. So now we will go the Spark use cases of datasets. It may seem redundant to have datasets which when we already have data frames, right? But there are certain scenarios in which datasets are better fit than data frames, right? That some operation cannot be expressed with the data frames, but only with datasets only we can do those operations. Consider the desired type safety. For example, attempting to multiply two string variables in the code will fail to compile time instead at runtime. So compile time fail and runtime is better always well. Additionally, development may be helpful as ID and other tools can provide autocomplete and other hints when the objects are strongly typed. So another reason use the dataset is the one of the data and transformers aspect. So there is one more reason, aspect case classes in Scala. It's a tribal reuse. So case class we can reuse and it can distribute it across the. So it's a benefit. So let's do one example. So I have created a Spark application. This I'm going to put into Git, and I'm going to create here is a row. So I have imported these rows and created this one, and I'm trying this string and I'm trying to convert it into the integer. So it's giving me a runtime error. Java string cannot be cast, right? So this is the benefits, like it is strongly typed. So this is just a introduction section about datasets. In the coming lecture, we are going various examples. Please like and subscribe my channel. Thank you for watching.